Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC B0079-13, indicates there is an open circuit or increased resistance in the driver's seatbelt outer lap tensioner system. This tensioner is critical in ensuring the seatbelt performs effectively during a collision, helping to secure the occupant and enhance safety. The driver's seatbelt outer lap tensioner is typically located within the seat assembly, near the B-pillar area of the vehicle. The tensioner must react appropriately during sudden changes in motion, and increased resistance can affect this functionality. When diagnosing this issue, it's essential to determine any prior collision history, as this could impact the components involved. Proper installation and functional integrity of involved parts are vital for the driver's safety, which is why thorough diagnostics and checks are necessary before concluding any repairs. The B0079-13 code specifically points to the driver's seatbelt outer lap tensioner, a crucial component responsible for maintaining seatbelt tension during a collision. This component is essential in ensuring that the seatbelt holds the occupant securely in place, reducing the risk of injury. It is situated on the left side of the driver's seat, where it connects to the vehicle's wiring harness. If the tensioner malfunctions due to an open circuit or increased resistance, it may not respond effectively in an accident, greatly compromising passenger safety. It's essential to be knowledgeable about its placement and operation, as well as to run checks on other components connected to the seatbelt system to identify any additional problems. Therefore, a thorough understanding of the seatbelt tensioner's role and location is crucial for accurate diagnostics. The causes of the DTC B0079-13 can stem from several factors within the seatbelt tensioning system. An open circuit in the wiring could occur due to damage, disconnection, or corrosion, preventing a complete electrical path necessary for the tensioner to operate correctly. Increased resistance could be due to wear in the connectors or faulty components that disrupt normal operation and signal transmission. Additionally, the seatbelt tensioner itself could be defective, which might require replacement if diagnosed as faulty. Furthermore, external factors, such as previous collisions, could have compromised the integrity of the wiring or connectors, leading to this error code. Each potential cause requires careful inspection to ensure that the correct issue is identified and resolved. The symptoms accompanying DTC B0079-13 typically manifest as a warning light illuminated on the dashboard, alerting the driver that a fault exists within the seatbelt system. In addition, the seatbelt tensioner may become inoperable, resulting in an inadequate response during a collision, which can severely impact a passenger's safety. You might also notice a lack of proper tension when the seatbelt is engaged. These symptoms not only compromise safety, but also indicate that the seatbelt system may not comply with safety regulations. If these symptoms are observed, immediate attention is warranted to assess the cause of the fault and to remedy it. Addressing these issues promptly is crucial for maintaining vehicle safety and ensuring the effective performance of the safety systems. The first troubleshooting step involves clearing the DTCs using the Honda Diagnostics System, HDS. Once the codes are cleared, it is crucial to ensure that the vehicle hasn't experienced any collisions that might affect the SRS, Supplemental Restraint System components. In case of a collision, all related components must have been correctly replaced with new parts that match the specific part numbers required by Honda. Additionally, it is vital to verify that these components were installed properly to ensure functionality. Check that no mistakes in wiring or connectors exist and ensure alignment with the automotive industry's standards for safety and performance. This step is essential for diagnosing intermittent failures, as clearing codes may help the technician see if the code reappears without further issues. Following the initial step, the next phase involves turning the ignition switch to the on position, or alternatively, using the engine start-stop button to select the on mode for 10 seconds. During this time, it is important to monitor the system for any DTCs that might be present. After waiting, check again with the HDS for the DTCs to see if the B0079-13 code is still indicated. If the code reappears, it confirms there is an ongoing issue requiring further diagnostics. Conversely, if no code appears, it indicates an intermittent failure, suggesting that the system could be functioning correctly at that moment. This step is significant in understanding the underlying issues by verifying whether they are persistent or temporary, guiding subsequent actions. For the third troubleshooting step, turn the ignition switch to the lock position, or use the engine start-stop button to enter the off mode. Proceed to disconnect the negative battery cable to reset the vehicle's electrical system. It is essential to wait at least 3 minutes after disconnection, allowing capacitors to discharge fully. This process is crucial as it resets the SRS system and helps to clear any remaining voltages in the system that could interfere with diagnostics or repairs. Disconnecting the negative terminal also protects technicians from potential electrical hazards during the following steps. By ensuring the system is fully powered down, you're preparing for accurate and safe testing while eliminating false readings associated with residual power. Once the battery cable has been disconnected, the next step is to remove the left side B-pillar lower trim. This trim panel covers key components and is essential for accessing the driver's seatbelt outer lap tensioner. Carefully prying off the trim allows for greater visibility and access to the area where repairs will be needed. Underneath, the carpet under the driver's seat will need to be turned over to provide a clear line of sight to the tensioner. Once you have access to the area, be prepared to disconnect the driver's seatbelt outer lap tensioner 2-pin connector located on the left side wiring harness. This step is integral to allowing further inspections or replacements to proceed without any obstruction, ensuring every component can be adequately accessed during repairs. After accessing the belt tensioner, connect the terminals of SRS Simulator Lead L to the SRS Inflator Simulator, utilizing the specified 2-ohm connectors. Following that, attach the simulator lead L to the driver's seatbelt outer lap tensioner 2-pin connector on the left side wiring harness. This procedure simulates the conditions needed to test the functionality of the tensioner effectively. It helps determine whether the tensioner itself is faulty or if the issue resides in the wiring or connectors. After the connections are made, monitor the results carefully, assessing whether the tensioner behaves normally under simulated conditions. Any malfunctions noted during this testing phase will indicate where further investigation or repairs are necessary, providing clear guidance for subsequent actions. Upon completing the necessary repairs or replacements, the next crucial step is to verify that everything functions correctly. This involves rechecking the entire system for any remaining issues and ensuring that all diagnostic trouble codes, DTCs, have been successfully cleared using the HDS. Testing the seatbelt tensioner and ancillary systems will confirm that the repairs were successful and that the tensioner operates effectively. Furthermore, a test drive of the vehicle is recommended, allowing the technician to ensure that all safety systems are operational and that no warning lights are illuminated on the dashboard. This final step safeguards against any overlooked issues and assures the technician and vehicle owner that the problem has been rectified. Ensuring functionality is paramount for overall vehicle safety and occupant protection. Preventive maintenance plays a significant role in prolonging the life of automotive safety components, such as the seatbelt outer lap tensioner. Regular inspections can help catch any wear or damage within the wiring harness early. Checks should also focus on any connectors to ensure clean, secure connections, which are vital for system functionality. Additionally, keeping the software for the SRS unit updated can provide the latest performance metrics and error management capabilities. By conducting routine maintenance checks and addressing any concerns proactively, vehicle owners can safeguard themselves and their passengers. It ensures that all systems are working as intended and minimizes the risk of unexpected failures in critical safety components. In conclusion, diagnosing and repairing DTC B0079-13 requires thorough and systematic analysis of the driver's seatbelt outer lap tensioner system, ensuring all components are functional and properly connected. The SRS system is an essential part of vehicle safety and should not be overlooked, particularly in a family vehicle like the Honda Odyssey, where the safety of all occupants is paramount. By adhering to structured troubleshooting methods and regular preventive maintenance, potential issues can be mitigated before they escalate into serious failures. Understanding the complexities involved in automotive safety systems not only promotes accurate repair, but also enhances overall vehicle reliability and occupant safety. Ultimately, a proactive approach to vehicle maintenance ensures that you can trust your vehicle and its essential safety features to work when needed most. Please like and subscribe to the channel. See you next time.